Okay, so good afternoon at EHCC. I'm Nicolas BACCA, CTO and co-founder of Ledger. And today, unsurprisingly, I will be talking about hardware wallets. And most specifically, I will be talking about how we can use hardware wallet to harden decentralized exchanges. So that will be mostly a list of issues I have run into while trying to do so, a few solutions, and a lot of open questions for everybody that we can discuss after or later tonight during the nice party that Asset will be organizing. So, first a reminder, I mean, just in case people here don't have many heads or are not very familiar with hardware wallets. So the goal of a hardware wallet is to protect your private keys, because if we look at the traditional user computer on the left, it's not very well protected and it's not in a very good state. So you want to protect your assets, your private key, against people that might want to steal them, or against people that might want just to corrupt what you are doing for whatever reason, for fun, for sport, or anything. You have plenty of ways to corrupt your actions on Ethereum because you are interacting with smart contracts. And basically, the goal of the hardware wallet in that case is not just to protect your keys, but the hardware wallet must tell you exactly what you are trying to do and how you are trying to interact with your contract. So on Ethereum, the hardware wallet has a specific functionality of letting you know that you are doing the right thing. So for example, here, if you are playing a dice, you want to know that you are rolling the dice. You don't want to be performing any other action. So the hardware wallet should be smart enough to let you do that. And that's one of the reasons why interacting with decentralized exchanges is interesting. So why? So first, because I think the architecture of decentralized exchange is pretty interesting by itself. So it's kind of the ultimate step into decentralization. Today we have a lot of systems. So most of the exchange are centralized. We have a few hybrid systems like Finex, for example, using the liquidity of centralized exchanges with peer-to-peer aspect of decentralized exchanges. We have fully decentralized exchanges like AirSwap, 0x. So we have seen the presentation before. So the architecture is interesting, and it's a good match for hardware wallets, because hardware wallets are a mean to own your keys. And coupled with decentralized exchanges, it would be a full way to trade freely. You have your keys, you have your transaction, and you can check both. And yes, another thing is that it's an interesting problem because it brings a lot of new usability problems that can help hardware wallets be better, and it can improve hardware wallets for all kinds of contract-based applications. So first, you need to have your hardware wallet interacting with your DEX as easily as possible, which means it should be transparent to integrate your hardware wallet into your browser. Then you have to provide clear information to the end user. You want ideally to visualize your trade or the action that you are performing in a very clear way. And you want to prevent creative scams, because decentralized exchanges and smart contracts in general can open the door to a lot of very nice scams. So today we have only seen, I would say, very common or boring scams, but I will get a bit more into the different security issues that we have, and we'll see that there is still a lot of potential for people who would like to steal money. So where are we today? So first, maybe to start with what we have accomplished so far. So mostly thanks to the Ethereum community, because we provided the APIs, but everybody has been doing the integration by themselves. So thanks to everybody here. So we have been integrated into the 0x protocol and relayers. So basically an integration into the 0x.js library, and then having the hardware wallet playing fine with all the websites. So we are into Radar Relay, Paradex, DEX, and we have been integrated into other specific exchanges which have their own protocols, so EtherDelta, Kyber, and IDEX. So I might forget a few people, so sorry about that, and more people are working on it. So why are we here today? We are here today because we have a nice JavaScript API that people can look at, and that will let you integrate a hardware wallet into your dApp very easily. So the initial integration was done, I did it for my Ether wallet about 2 years ago. It has completely changed thanks to Gaetan, who has been repackaging our applications into something that looks into a proper JavaScript project. So if you looked at it in the past, I would suggest giving it another look, because now it really looks very nice. I mean, it's completely different. So we have a sub-provider if you want to integrate into something like MetaMask and couple it with another Web3 provider. And we have a starter kit if you want to design your own application and you want just to access the hardware wallet. So you have, with those two links, you should find anything you want. Then, why are we working? So why are we working fine with the browser today? So first, we are looking to have a plug-and-play integration into the browser. So if we look a bit into the standard, we started from something completely different. So we started from U2F. U2F is supposed to be the modern and phishable protocol, which is based on a cryptographic challenge between a website and a physical token. So it's something that was developed by Google in 2012, I think. The idea is that you have two sets of messages: a registration where the device is generating a private key and returning an encrypted private key to a server. So which means that you can have an unlimited number of websites handled by a simple token. And then an authentication where the token is performing a challenge against what the server would be asking. So you will be sending the private key encrypted to the token. Token will decrypt it, sign the challenge, return the signature. So here, from there, you might wonder, how are we talking to a hardware wallet using that kind of protocol? Because that's an authentication protocol. That's not something to call a smart contract. So here is the catch. We can use the key handle here, which is just an encrypted blob, to pass a command. And instead of a signature, we can send back a response. So by doing that, we managed to have a simple hack on the U2F protocol and turning it into a kind of a proxy, a tunnel, to be able to talk to any kind of device. So there are just two drawbacks. So first, it's a hack, so it might be removed, but so far it has been working well for more than 2 years. We have no events when the device is connected or disconnected, which is kind of a limitation if you want to perform, if you want to have a nice UX, but we can still work with it. And on the plus side, the application ID is a browser-guaranteed hash of the web origin you are currently browsing. So we'll see where we can use that, but it's very, well, it's a nice feature to have because basically the device knows where it is on the web, and we can use that to provide more information to the user. So that's what we have today. In the future, we want to move into standards, which will be a bit more standard. So WebUSB will be a good start. So WebUSB is not a hack, so it's a proper protocol to talk to a USB device on the web. It will have mobile support, so at least on Android. You will get device connected and disconnected events, but you lose the web origin. And I would say that WebUSB had kind of a bumpy start so far. So it has been integrated into Chrome. It was disabled recently because people realized that it gave a way to access U2F tokens, some kind of U2F tokens differently. So people managed to phish the unphishable protocol using WebUSB by basically connecting to an interface that was not enumerated and accessing the U2F applet in a way that was not supposed to be done. So basically changing the origin. And another way to move to a plug-and-play browser integration will be the web Bluetooth protocol. So for different kind of hardware wallets that will be able to communicate with mobile devices. So when we do that, we have basically a protection of private keys when we want to transact. But there are lots of other attacks that can be done on the decentralized exchange. So first, we can wonder if we are interacting with the right website. So that's the simplest kind of attack. Then, are we interacting with the right smart contract? What can be changed on the contract itself? Then, the token will be swapping, the website will be swapping tokens, but are we interacting with the right token? I mean, can we be fooled into swapping something that we didn't want to swap initially? And then, a more specific attack on the protocol itself. When we're interacting with a smart contract, are we really passing the right message? For example, 0x is based as a protocol to define orders. What happens is if those orders are different, and how can we display them properly on the hardware wallet? So first, the integration with the right website. This has been a source of attack in the past. So for example, with EtherDelta, which was, the DNS was changed when the website was acquired, and well, it was a very simple attack, but people managed to collect private keys. So U2F here can help if we look at the application ID, because it means that we have a way to if we are able to make a map between the hashes and the website, the hardware wallet will be able to display the information and will be able to verify that we are really interacting with EtherDelta, for example. Problem is that if we do that, then we realize quickly that we need a trusted store of web origin hashes. And well, for people who have been watching the TCR talk yesterday, so for the token curated registries, they have seen that it's an open problem. And on a hardware device, it's even harder because we have really no way. I mean, if we want to have a trusted store of something, we would basically need an external party to do it, to sign it, and to pass back the token to the hardware wallet, so not very convenient. Then how do we verify that we're interacting with the right smart contract? So on that, ENS can help on the host because we can map names to smart contract addresses. But if we want to validate ENS on the device, then it's more complicated because, of course, the device has no real access to the blockchain and cannot really verify the state of an ENS name. Another problem is that ENS is not going to prevent current attack on website, which is typo squatting. So if, for example, you have EtherDelta and somebody is registering EtherDelta with 2L or 1E, replacing the L, it's not going to help a lot. So again, it looks like we need another trusted store, but this time that can run on the hardware wallet also, and mapping smart contracts to their names. Now, interacting with the right token, again, it's still a naming problem. So token is represented as an address. We need to have a way to map token names to token addresses. So another trusted store. Starting to get, well, a bit boring here. Now, how are we going to verify that we are communicating right with a smart contract? So for that, we need to validate the ABI. But validating the ABI on the device itself will provide a very poor UX because we don't have a very specific name in the ABI, and people don't want to read binary. So you don't want to verify when you see a trade, you don't want to see the hexadecimal data that you are passing and validating what you're doing. So here, you might also need another level of abstraction when you interact with the contract. For example, a blob can be a message, a blob can be an order, or a blob can be an address. So how are we going to display that on the hardware wallet? And what kind of specification can we have for that? If we look at the argument of the smart contract, let's say we are going to sign a message. So if we sign a message, there is an EIP for easier message signing, where you can pass the argument of the message and verify that you are correctly signing the right argument. So you would get an information, for example, that this field is a string, this field is an integer, and display it that way instead of displaying a binary blob. But here, we also have a UX problem. It's still too low level. Typically, there is a field in the 0x protocol, probably not very visible here, but there is a time at some point. The time should be represented in a way that is readable by the user. So do we want to present an absolute time? Do we want to present a time related to a current session? Do we have a source of time in the wallet itself? So you see that in that case, trying to make something generic is still very hard. So proposal for that, reverse a bit the problem and think that we won't manage to create something that is completely standard to display what a contract is doing and to sign messages, and turn into small applications that we can basically provide along the DApp, which will be loaded into the hardware wallet, just adding a few additional trusts to the different hardware wallet manufacturers. So here, I said, okay, we have 2 hardware wallet manufacturers. Of course, we can have more. And they will just provide authorizations. So first, they will manage a trusted store of tokens. So they can give you an association that will map the token to a name. And regarding the code, they can give permission to the contract author to write an application that will handle transactions specifically for his contract and that can sign messages that are matching the EIP 712 description. So that means that here we provide a responsibility from the hardware wallet to the DApp developer to create a small application running on the hardware wallet that will be responsible for signing transaction going to this address, messages mapping the specification, but leaving a full UX rights to the developer. So that way, we can imagine a set of small applications that will be loaded along the DApp, and on which people will just be able to handle everything regarding the UX, while interacting only in the scope of their contract. So this is an additional protection, I would say, to what exists today, because today, so hardware wallets are only running application signed by the manufacturer, typically. Here we would run delegated rights for application related to specific contracts. So what would we need for that? Dynamic application management on the hardware wallet first. So that's something that we already have in our infrastructure, and that's going to be, I think, not too hard to make with third-party architectures. For example, a lot of people are looking into Python today. If you want to make something like this in Python, you won't be able to do it directly with the scripts, but we could think about a language running on top of Python which could describe that. So the issue is still to map a UI to different devices, because hardware wallets can have very different UIs. So some will have a screen, some will have a touch screen, some will have a color screen, some will only have a few LEDs, a few buttons. So it's better if that part is native and still belonging to the hardware wallet manufacturer, but that's open for discussion. If we want Standardized API, what do we want this application doing? So it needs to sign things, for sure, but does it need to do more? So still open for discussion. And what kind of language can we have for that? So Python can be something to look at, still a bit complex to run for some architectures, something else, so still open for discussion. Today, with our architecture, we can design third-party application in C. So that's what we have been doing for a few decentralized exchanges. We would have some things to show on that so shortly, I would say in the coming months. So we would have those dapplets running along the main Ethereum application and able to display specific messages regarding the smart, regarding the DEX, which is currently running. So, well, in our architecture, we just design applications that way. That's fully open for discussion for other architectures, of course. And, well, we're interested to think about ways to describe how those small applications could look like, and if people would be interested to run them on other medias. So, thank you.